So I was given this 50-inch Samsung, which is a PS50B430. It's a 50-inch plasma, I think from around 2012 or so. But anyway, this one is faulty, and the customer's saying that it's clicking on and off when you connect it to power, which I've fixed maybe around 20 of these TVs. So I haven't even plugged it in yet. I've just whipped the back off straight away. And what I've had on these a lot is the X-main tends to short out. There's some transistors, which I don't know if you can see. Doesn't look too healthy on there already. There's some transistors that get really hot. Then the solder joints on them break, and then they end up shorting out. And I think that's probably what's happened on this TV. So I'm going to run through the diagnosis with you. It's a pretty common failure. I've had it loads. As I've said, I've probably fixed around 10 or 15 of them X-mains. And I've had pretty good luck with the Y-mains being okay as well, because the Y-main and the X-main share a circuit called the energy recovery circuit. And this can actually cause both boards to go faulty if one of them shorts out on the energy recovery circuit side. So depending on how badly shorted out the X-main is, the Y-main could also be faulty. So what we're going to do is we're going to check for a short circuit on the main VS power rail. And then if there's no short circuits there, we're going to look around for other things. But if there is a short circuit, I'm going to start disconnecting the boards one at a time. It's pretty easy to do just on these Molex connectors. And we're going to see if we have a short circuit. So the clicking noise as well that the customer stated is these relays here, these power relays. These basically allow power to go to the main PFC section and main switching section for the higher voltage rails. So straight away, if there's an issue with these rails, this section will come up. It'll try to bring up the output section, and then it won't work because it'll be drawing too much power, and then it will shut down the rail. So at the top here is where the Y main gets its main power feed from the power supply. So, and this one is where the X main gets its feed from. What we're going to do is look on here, and you should see VS voltage. That's your main plasma panel voltage. And you got your VG and your VA, which is for the address buffers. So all we're going to do is put the meter into continuity mode. I'm going to check between VS and ground, which there is a dead short to ground. So what we're going to do is we're going to start at the X main. Just going to unplug it, and if the meter goes to OL, the Y main is probably okay, but we're still going to check it. Let me reverse these leads. If it goes to OL, I'm going to assume the Y main is probably okay. There you go. Okay, so the Y main probably doesn't have any short circuits on it, but we're still going to pull it out and test it. We're going to keep the buffer connected as well, because we can test for short circuits on these outputs. And if the buffer is shorted out, normally you'll get a dodgy reading on these transistors, normally a low ohms. And you can also check on the buffer card as well itself, on each individual output of the ICs to see if there's any short circuits. But if the Y main's okay, the buffer is likely going to be okay in this TV's case anyway. It's probably just going to be the X main again. So, but we're going to check both of them together just to ensure that when we fix this, this isn't going to blow that out again straight away, because I've had it happen. So you've got to be careful on these Samsungs. And also we're going to remove the power supply. I'm going to resolder any big power devices, because Samsungs have a bit of an issue with solder joints, especially these plasmas. So it's a good idea to just rip out these boards, Just give it all a refresh. That's what I'm going to do for the Y main as well. And I mean, will that come off? I normally reset the thermal paste on here, but I think that might be stuck on too hard. And obviously I'm going to clean out all this dust. So I'm going to do that now and unscrew these boards. So I thought I'd just show you real quick how to get these boards out. It's pretty easy. Take out all 4 screws on this X main. Then you've got this panel connector. Undo the latch. That just simply comes out. And then you've got a ribbon cable here, FPC, just comes right out. Then there is a thermal pad that holds this board down. You will have to break that free. Other than that, nice and easy. That looked a bit rough, I know. But yeah, here's the X main. Let's have a look. See if there's anything obvious. Well, there is. What the? I've never seen that. The PCB is actually delaminating itself. Is that a via right there? I think that's a via. I don't know if I'm gonna have to maybe run that as a trace maybe, but yeah, so the PCB is delaminated. So it's gotten that hot in this area. This 30F123 transistor, this one, it's actually delaminated the board. And there's a little solder point there, so it doesn't go through to the other side. I don't know what that's for. Yeah, but that's pretty bad, that is. I've never seen one of these boards cook themselves that bad, but you can see the issue straight away. As I said, that is completely broken, that solder joint. I mean, the ones on the FETs ain't too bad, but that diode's connected up after these FETs, and these are being driven. That's completely broke. Yeah, down here too, look. The diode isn't as bad, but this transistor, it's getting bad, and this, you can just see it. I won't be able to wiggle it with just that, but the output side, these never normally are as bad, but they don't get as hot. I mean, that rivet, no, it's okay. Yeah, these ain't as bad on the output side. I mean, that's bad. But yeah, we're gonna have to check for short circuits on here because there's gonna be a couple of parts showing up as shorted, and we're gonna have to pull them off to see what makes the short go away. Or the other alternative is if it's cheaper to buy an X main, I will just buy an X main. But we need to pull the Y main out now, which again is a similar process. Your panel connectors here, they just fold up, push down, it should just slide out. There you go. Nice and easy. So I'm going to take out the Y main and the power supply. Okay, so I've got the power supply and Y sustain taken out. I've actually left the buffer in the TV because I've done a few tests and there's no short circuits on the buffer card, so hopefully the Y main should have protected itself and be okay. But you always need to pull these out, especially these single layer boards. Even the double layer Samsung plasma sustain boards, you've got to pull them out because it's just always the case. There you go, bang, bang. It's not as bad, but yeah. All the transistors all the time need solder work doing to them. Oh, that one is really bad. I'm actually gonna, I haven't checked these yet, but I'll check them tomorrow when I'm testing the rest of it. But yeah, you've got to resolder them, and same for the power supply. Power supply isn't nearly as bad, but it is starting to go. You can see it starting. A couple more years of heat, these will be broke. I mean, it's just like the solder quality that Samsung used. There you go, right there. That's why you gotta check them all. It's like the solder that Samsung used was like rubbish or something. I don't even know. Yeah, so what I'm going to do is get desoldering transistors on this X-main and see what other parts are faulty, because it's not just the transistors that go faulty on these, there's other parts that can fail too, so I'm going to test all of those as well. It's all part of the fun. Okay, so it's about a week or so later since I started doing this TV. And as you can see, I've actually ordered a second X-Sustain board for this TV rather than repairing the original. And I'll tell you why in a second. Here's the replacement though. As you can see, it is a lot healthier. There's no browning or scorching going on by these FETs over here. Or IGBTs. There's nothing nasty going on the board. I did have to fix a few of the solder joints. They were a bit rough. I did notify the eBay seller. As you can see, I've just gone over all these. Gone over a few over here. Just done all of the non-riveted joints basically. And it should keep this board running nice and happily. So I've checked for short circuits. There's no shorts going on, there's no dodgy resistances, there's nothing like that. So the X-Sustain is all good. Done the Y-Sustain here, as you can see. I've resoldered quite a few things because there was some real rough solder joints going on. This trace here was actually delaminated. I belled it out though, it's all good. But yeah, I've gone over quite a few different points on this board because there's quite a few joints that were pretty bad. But there is no short circuits on the Y-Sustain, so I'm pretty happy to say that that's going to be working good. What I've also done as well as any screws that you can get access to, I've just tightened up, because you can actually get a good couple of turns on quite a few of these screws. So this is the old X-Sustain, and there's quite a few parts that were faulty, and I'll explain why I ordered a new one rather than fixing the original. So these are all the transistors, and there's 5 transistors there, I think. Yeah. And the transistors themselves are only about £2.50 each. So you need 5, so that's just over £10 for the transistors. And I would have ordered them if it was only just the transistors that were faulty, but it isn't. So as you can see, there's this one here, and then there's 4 on the other side that were faulty as well. But unfortunately these, as you can see here, this one's actually physically blown up. This little IGBT driver was shorted, so is this one, and so is this one. Unfortunately these are £14 each from a reliable seller, and these have a weird part number. Samsung actually scratch it off so you can't see what it is, but they're like HBO, or no, not HBO, HB830019 something. There's some really weird part number for an IGBT driver, and I did try finding equivalents, but I couldn't find any, and these are now £14 each. And I couldn't find any on like AliExpress or anything, so I sort of give up on this board. And wrote it off. So the replacement board was £30 odd off eBay, so it's not too bad. So I'm going to put it all in and hopefully it works. And here's the power supply as well. Just gone over that. Tidied up a few of these. Soldered the transformer because that was pretty rough. Gone over anything on the heatsink. And we should be good to go. So I'm going to put all the boards back in. You want to make sure you put all of your grounding screws back in properly. Those aren't the grounding screws. These are the grounding screws. Because as you can see here, there is capacitors. X-class capacitors straight onto chassis ground. You want those connected on the Y sustain and X sustain because they use these for decoupling. So if you don't have those connected, the voltage on these IGBTs is going to go way higher than it should, and they're going to blow out. So you don't want to blow those out because you're going to blow out the X sustain, and you don't want to blow anything up. So make sure your screws are in properly and tight, all your connectors are in, and we're just going to give it a straight fire up and it should work. Okay, so this is going to be the explosion test. Got everything plugged in. And we're on standby. What's going to go bang? Nothing. That's up and running. So I've got my meter hooked on to the VS rail. Listen to that. Buzzy buzz buzz. Oh, you can really feel the power going through this thing. Yeah, so excellent. So we're up and running. I'm not going to leave it on long because obviously these heat sinks are designed to drag air upwards and through them. We don't want to overheat anything. What I'm going to do is I'm just going to leave it on for 3 or 4 minutes just so the panel gets fully primed, and then what I'm going to do is adjust the VS and the VA voltages. On these ones, on these later Samsung models, normally if VS is a little low and you adjust it to what the panel says, which is 209 volts, we're at 207 at the minute, but we're going to see if that changes when everything heats up. Normally on these ones, if you adjust it to what the sheet says on the panel, you're normally okay for mal discharge. Obviously, they do mal discharge anyway. But normally keeping VS at what the panel states it should be at on these normally makes the displays look okay. On older Samsung plasmas, I've found myself having to put VS up a couple of volts higher than it states, just to help get rid of mal discharge from cold starts, because they really do suffer. The older LG plasmas aren't nearly as bad, but I've found myself on LG plasmas having to really adjust the voltages to get them to look okay. But the C and B series and the D series Samsungs, they're normally pretty okay. So I'm just going to let it do whatever it's doing for a few more minutes, and then I'm going to put that up to 209. I'm going to check the VA voltage as well, and the VSC voltage, which is on the Y sustain. There's a test point there and the adjustment pot for it. So we're just going to check all of these out. If they're all good, then basically it's put the back on and check for any lines out in the panel, because if there is, because these B series ones, the address buffers at the bottom here have like no heat sinking whatsoever, so the address buffers do become faulty on them after a while. So if you do get any coloured lines out or black spots in the panel, you can have a look at the address buffer. I've had luck one time applying a big thermal pad to push down on the ribbon, and it did actually repair the panel. But normally if you get a row out in the panel, an addressed row, the panel is a write-off. So You can't do anything with that. But anyway, the TV's up and running, so good news. So I've just got done adjusting all the panel voltages, and I thought I'd do a quick temperature test for the 5 minutes that I've had this thing turned on for. And my little temperature scanner. So as you can see, we're getting hot already, and this room is cold. This room is probably about 16 degrees right now. As you can see, they do get hot fast. 34 degrees on that. 33. And this is pretty accurate, this little reader is as well. The scan ICs don't normally tend to get too hot on these. Obviously after a lot of writing to the panel, they probably do get up to about 45 degrees or so. The power supplies normally are okay on the B series. They're a lot more efficient than the original Samsung plasmas. Bet you this is going to be hot. 46 degrees right there. I've only had this thing on 5 minutes. 45. That's 49. Was that the heat thing? So yeah, maybe that's where we go wrong, is we get too hot. Samsung didn't put adequate enough heat sinks on these devices. I'm pretty sure it's displaying a raster right now, so there is quite a lot of white in the image, I'm guessing, because you can hear it buzzing quite a lot. White does use up the most power. Yeah, that is getting hot fast. And already, like, that's like almost uncomfortable to touch. Right there it is. Like, it's almost hotter than my radiators, you know. Don't touch that heatsink with your bare hands, because that carries your AC. Power supply doesn't really get that hot. But yeah, where Samsung went wrong here is they should have added fans directly above these sustain boards. Would have made them 10 times more reliable, and we probably wouldn't have these issues. And these TVs probably would have lasted a good few years before they was all thrown out. So, nice one, Samsung. Anyway, going to put it back together. Okay, so this is going to be the first power-up test. We'll see how bad this really is. And that's actually pretty stable. There's a little bit of mild discharge, but that'll probably go away as the panel heats up. Yeah. See the blue pixels there? That'll probably stabilise as the panel gets a bit more warm. But that's not too bad compared to others that I've seen. Doesn't look on like a black screen. Yeah, that's pretty stable. Especially for an older Samsung. They're normally worse than this. So, I'm going to say that that's fixed. So I'm going to run it for probably 3 or 4 hours and then let it cool down, because these get hot. And then I'm going to give it a clean and then give it back to the customer. So, yeah, thanks for watching, and hopefully you enjoyed. So, that's how to fix a Samsung B series plasma.